there's a particle that then the first thing is you have to know the sequence of events. Then you apply the maths. So the first sequence they were together, there was no acceleration. They were somebody holding it. Then he drops it. So this guy starts has a reaction upwards. He's got a weight which are being balanced, but he's got a tension pulling him, and he's got a friction acting backwards. These are the two forces, and tension minus friction is Ma. Here, this is mg. There is tension. Tension minus mg is equal to Ma. So, sorry, mg minus tension is equal to Ma. So you solve these two. That means he's doing this tension. This is the A body. This is mu r. So this is the causing acceleration on the A body, and this is the next one. That means mg is zero point 0.7. This is zero point 0.7 into 10, which is 7, and 7 minus t is equal to zero point 0.7. So he solves this and he gets acceleration as 6.4, and he gets some tension, but tension is not requiring. So he's not using, he's not even you're not being asked also. Then the problem comes. He's asking you to calculate the speed of B before it hits. So there are three motion. One is B moving connected, B moving connected. So the B will have a velocity caused by acceleration, final velocity because you're zero. So V, final V just before it disconnects. So that he solves. So this is what he does. He finds the final V using this acceleration and the time. Time was 0.25 seconds. He's still connected. And U, because it is from rest, so he gets a V of 1.6. So he gets a V of 1.6, and that 1.6 is now the initial for the second event. That means B moving after disconnection. Now, after disconnection, this V becomes U, acceleration becomes G, and the time we don't know, but we know the distance remaining. So first he calculates the distance. So first he calculates the distance for 6.4. He gets the distance, he subtracts it from the 0.5 total because the total distance was 0.5. The total distance is 0. So he finds how much distance is remaining. And that distance then he uh, he uses that distance. The distance is 0. This much distance is 0.3. So he's asking this distance he's using g to v square is equal to u square plus 2as. The original speed he gets while they were connected was this, and then g he uses, and then he gets the speed at before it hits the floor. And the length, the for that second part, that means the total distance traveled by A. So first he finds uh, the this thing that means the distance this guy moves while they were connected. So this will also move. So he had moved how much distance here? He had moved zero point 0.2. So this will also move zero point 0.2. So this will also move zero point 0.2. But then after that, this will break. Then because of some velocity, it will start moving and it will stop because there's deceleration happening because of friction. So he finds the deceleration, which is 2. Initial velocity is the same velocity of this B when it was connected, and then how much it became 0 in how much distance he uses. V square, this distance traveled is S is equal to V square minus U square by 2A. So this is 0, so it stops 1.6, and this was the acceleration because of friction. 2. Then he gets this distance. This is the total distance. Understood?